Good morning, children, and welcome back to physics class. In today's class, we are going to start with the fourth chapter, motion in a plane. Alright, so in the previous classes, we have completed with units and dimensions, then motion in a straight line. Now we are going to start with motion in a plane. Alright, now before I go ahead with motion in a plane, what do you mean by all of that? Some things that we all have to know. The first thing is, on the basis of magnitude and direction, every physical quantity, what is a physical quantity? Any quantity that can be measured is called as a physical quantity. So this physical quantity is divided into scalar quantity and vector quantities. Alright, now what are scalar quantities? Any physical quantity which has magnitude but no direction are called as a scalar quantity, like time, mass, distance, right? So all of them have magnitude. What is magnitude? A numerical measurement, basically, right? A numerical value. But they do not have direction. Where are they going? Are they going east? Are they going west? Right? So they do not have direction. Whereas vectors are the quantities which have magnitude and also direction. Okay, now what do you mean by magnitude? Some numerical value, okay, some distance it has covered from 2 points. And we also know if it is covering distance in 2 points, then we know in which direction that quantity is going, right? So that is called as vectors. Now, scalars, you can simply add them, you can subtract them, you can multiply or you can divide. But when it comes to vectors, we have to apply some basic law of vectors, okay? So we have vector addition, vector subtraction, and all of the different types of operations are involved here. Alright, now some of the examples of scalar quantities are mass, distance, time. So all these are nothing but examples of scalar quantity. But when it comes to vector quantity, it is nothing but displacement, velocity, right? Then we have acceleration, force. All these are different examples of vector quantities. Now let us study more about them now. Now the magnitude of vector is called as the absolute value. Alright, so whatever the magnitude of vector is, now though it is, suppose the magnitude of vector is -5, so if I am putting an absolute value to it, that is delta magnitude of v, I will get mod of -5, which is again 5. So magnitude of vector is always the absolute value. It's always positive. Then vector is also represented by this arrow and this way. Alright. So this is called as the starting point. Okay, the end where it starts from is called as the tail. Alright, and this P is called as the head. That means this is the ending point. So where it starts, it's called as a tail, and where it ends, it's called as a head. Alright, so this O is called as the tail, and it ends at P, so that is called as the head. So that's why we have represented this as OP and one arrow on the top. Now, vectors are classified into two types. There are polar vectors and there are axial vectors. So what are they? Let us check out. Yes, children. Now I'll tell you what do you mean by polar vectors. Okay, so polar vectors are nothing but the vectors whose starting points are known. Alright, now vectors which have a starting point or the point of application, that means I'm starting from here, right? Such vectors are called as polar vectors. Example, let me take this as an xy plane. Alright, so in this xy plane, what happens is, let a car start from this position P and it is going by the application of force, right? So once force is applied, it moves its path, correct? So by application of force, it goes in the x direction and it displaces itself. Therefore, we can say that force is a polar vector. Why? Because the starting point of this force is known. Such vectors are called as polar vectors, right? So application, the starting point application is known. So such vectors are called as polar vectors. Just think that polar vectors are nothing but we know the location of it. We know from where they are starting. Clear? Alright, so now we'll go ahead with what do you mean by the second type of vectors, that is axial vectors. Let's get started. Yes, children. Now, moving ahead with the second type of vectors, they are axial vectors, right? So, axial vectors basically are seen when it comes to rotational motion or the vectors which show rotational effect. Okay, so axial vectors are nothing but vectors which represent rotational effect, right? So, which act along the axis of rotation, right? Now, what happens is when you look at a door, right? So, the door is moving from this end to this end, right? So there's a rotational effect, and torque is acting perpendicular to the rotating body. So in a rotatory bob, okay, let me take an example of a rotatory bob, right? So take a bob and just wind it round. Okay, so the bob is rotating. What happens is along a circular motion, angular velocity and torque act on each point of that bob. Yes or no, children? So if I'm rotating it this way, every single point there is angular velocity at each single turning of that bob, and also torque is acting on each other. Now hence angular momentum, if there's angular velocity and torque, we can say that yes, there is angular momentum which acts there. So angular momentum is called as the axial vector. So the vectors which are in contact, which are coming in rotational effect, are called as axial vectors. Now the direction. So how is the direction? Since it's a vector, direction how can we find out if the vector is nothing but it's in rotational effect? So it all depends if it is rotating in the anti-clockwise direction or clockwise direction. So either in the two manners we can say. So if the vector is in anti-clockwise direction, that means like this, then the vector is going upwards, right? If it is in the clockwise direction like this, then it is coming in the downwards direction. So this is nothing but axial vectors. Remember, axial vectors always act in the rotational effect. Okay, so whenever any kind of body experiences a rotational effect, that means you should say that yes, axial vector is present there.
Vectors are represented by drawing arrows. Now, the length and direction of a vector should be drawn to a reasonable scale size and show its magnitude. So we have to, not draw it too long, neither draw it too short. Okay, so the length signifies its magnitude as well. Now, there are various application of vectors, right? So we have vector application, in that we have addition, subtraction and also multiplication. So in addition of vectors, when two vectors or vector points are in the same direction, then we simply add them together. When vectors are added together, they should be drawn head to tail to determine the resultant or sum vectors. Okay, so whenever the vectors are added, they have to be added from head to tail, from top to bottom, and that gives us the resultant or sum of that vector. Now the resultant goes from tail of A to the head of B. Now let's practice one question. A man walks 46.5 meters east and another man 20 meters east. Calculate his displacement relative to where he started. Can you see here? So you see from one point to the other point, again from the other point to the next point. So red symbolizes 46.5 meter east, again 20 meter east, which is symbolized by the blue line. So together when we see, it is 66.5 meter east, which gives us the displacement. Similarly, there is one more application of vectors, that is subtraction of vectors. When two vectors point in the opposite direction, then we simply subtract them. Okay? Now let's practice one more sum. A man walks 46.5 meters east and another man 20 meters west. So east and west are two opposite directions. Calculate his displacement relative to where he started. So from one point to the other point and again from the other point to back, right? So you see there that they are opposite in direction. Hence we say we subtract 46.5 from 20 and finally we get 26.5 meters, that is east. Now we can use even graphical method as well. Now aligning vectors head to tail and then drawing the resultant from tail of the first to the head of the last. Again we can get what? We can again get the resultant. Now graphical vector of addition A plus B. First thing is, how do we represent A plus B? Okay, first we will draw a starting point. Next we will decide on which scale we want it. Then draw vector A to the scale Vector B's tail begins at vector A's head. Draw vector B to the scale again, and then draw a line connecting the initial point and the head of B. So this will give you nothing but the resultant. So first draw one point, decide the scale, draw which is the vector A to that scale, then draw the tail, that means vector A to B, right? So B's tail begins at vectors A, where A's head. So we will draw vector B to a scale and finally connect A to B, and which gives you the resultant like this, right? So commutative property is also valid for vectors. Now, what are non-collinear vectors, children? Non-collinear vectors means which do not have the same tail. Collinear vectors are the vectors which have the same tail, but non-collinear vectors are the vectors which do not have the same scale. Okay, so when two vectors are perpendicular to each other, we must use Pythagoras theorem. So let's practice. A man is traveling 120 kilometers east and then 160 kilometers to north. What is his resultant displacement, they have asked. Yes, so you see here, east, from starting he goes to east, which gives us the horizontal component. Then from the end point to, again goes up, that means the vertical component. That means you see here 160 kilometers north, right? So that gives us the vertical component. So join tail of the first to the head of the last. Second, so that hypotenuse gives you the resultant. So this gives us something called as right angle triangle, and we can apply the Pythagoras theorem to get the resultant vector. Like this. So root of 120 square, that is horizontal component, plus vertical component, when we take the root of it, you will get 4,000, and which will finally give you under the root 200 kilometers. Now what about direction? Now in the same example, displacement is asked, right? And since it is a vector quantity, we need to report its direction as well. Simply note that when drawing a right angle, that conveys some type of motion. So you must draw the components head to tail. That's the end. Oops. So this is in north direction, south direction, east and west. So this is north of east, east of north. This gives you south of west. This gives you west of south. This direction is north of west, west of north. This is south of east. And finally you will have east of south. So this is north of east. Therefore, there is a difference between northwest and west of north, right children? So northwest, which is like 30 degrees, and west of north gives us, west of this north, so 30 degrees to the downward arrow. So need a value or an angle. Now just putting north of east is not good enough. So how far north of east? We need to find a numerical value for the direction, right? So similarly, same example, 120 kilometers east, 160 kilometers north. So from the toe to the head, we got 200 kilometers. So therefore, angle theta is nothing but opposite divided by adjacent side, tan theta, right? So angle is this side. So this angle gives us tan theta, which is opposite divided by adjacent. Opposite is 160 divided by 120, that is adjacent side of the triangle. So when we solve it, we will get 1.33. So theta will be tan inverse of 1.33, which is nothing but 53.1 degrees. So to find the value of the triangle, of the angle, we use a trigonometric function called as a tangential function. So we say that the final answer is 200 kilometers, 53.1 degree north of east. So what are your missing components here? Suppose a person walked 65 meters, 25 degrees east of north. What were its horizontal and vertical components? The goal, always make a right triangle. Remember, to solve for components, that is x and y, we often use a trigonometric functions called as sine theta and cosine theta. So this is basically this entire stuff that they have told us. So here we know that the person walked 65 meters, 25 degrees east of north, they said. So what is its vertical component they are asking us, right? So to find the vertical components, we need to get what it is horizontal component as well, right? So we know that cos theta is equal to adjacent divided by hypotenuse, and sin theta is equal to opposite divided by hypotenuse, right? So adjacent is equal to what, children? According to cosine theta, cosine theta is equal to adjacent divided by hypotenuse. So bring this hypotenuse to LHS. So you will get what? Cosine theta into hypotenuse, it is equal to adjacent side. Here opposite is nothing but sine theta into hypotenuse. Correct. So therefore what I'll do now? Now simply put the values here. Adjacent vertical components is equal to 65. Why 65? Because it is hypotenuse. 65 cos theta. Theta is what? 25 degrees, right? So they have already given us. So cos 25 into 65, you will get 58.9 meters north. Similarly, opposite side is nothing but horizontal component, which is 65 sine 25, which will give me 27.47 meters east. I hope you understood.
Properties of dot product and the application of dot product. Now what is dot product? As we know that we can add two vectors, we can subtract two vectors. Now it is time that we will multiply two vectors. For example, if I have two vectors A and B, and if I multiply these two vectors and instead of multiplication sign, I put the dot sign between A and B. Now this statement will be read as a dot product of vector A and B. Now how we multiply two vectors? For example, if I have a vector P and its components is A, B and C, and let if I have another vector Q and its component is X, Y and Z. Now if someone is asking me find the dot product of P and Q, now what I will do, I will write the dot product of P and Q is equal to, I will multiply the X component of P with the X component of Q, and that is AX, and then I will put the plus sign. Now I will multiply the Y component of P vector with the Y component of Q vector, and that is BY, and then again I will put the plus sign, and now in the last I will multiply the Z component of P with the Z component of Q, and I am getting CZ. Now this is the multiplication of dot multiplication or dot product or scalar product of P vector and Q vector. Remember that the dot product of two vectors P and Q will always give me a number. Now for example, if I have a vector A which is equal to 2i plus 3j plus 4k, and if I have another vector B which is equal to 7i plus 5j plus k. Now if someone is again asking me find the dot product of A vector and B vector. Now here first of all I will take the component of A, and that is 2, 3 and 4, and the component of B is 7, 5 and 1. Now the dot product of AB is equal to, here again I will multiply the X component of vector A with the X component of vector B, and that is 2 multiplied by 7, plus similarly I will multiply 3 multiplied by 5 plus 4 multiplied by 1, and I am getting the dot product of A vector and B vector is equal to 2 multiplied by 7 and I am getting 14, plus 3 multiplied by 5 and I am getting 15, plus 4 multiplied by 1 and I am getting 4, and this is equal to 33. And now remember, as I told you that the dot product of two vector is giving me a number. Now 33 is a number. Now how we find angle between two vectors? To find an angle between two vectors, we use a theorem of dot product. Let the dot product of AB is equal to magnitude of A vector to the product of magnitude of B vector cos theta. Or we can rearrange this equation, and I'm getting cos theta is equal to A vector to the dot product of B vector divided by the magnitude of A vector to the product of magnitude of B vector. Now remember, theta is the angle between vector A and B. Now if I have a question, find angle between the vectors, A is equal to 2i minus 2j plus k, and B is equal to 12i plus 4j minus 3k. Now here I try to find the angle between vector A and B. Now the component of vector A is 2 minus 2, 1. And the component of vector B is 12, 4 and minus 3. Now I will use the theorem cos theta is equal to the dot product of AB divided by the magnitude of A vector to the product of magnitude of B vector. And remember, first of all, here I will find the dot product of AB, then I will find the magnitude of vector A, and then I will find the magnitude of vector B. And after finding these three things, I will put these three things in this equation, and the first equation. Now the dot product of AB is equal to 2 multiplied by 12 plus minus 2 multiplied by 4 plus 1 multiplied by minus 3. And I'm getting 24 minus 8 minus 3. And I'm getting 13. Now I will find the magnitude of vector A. And that is equal to 2 square plus minus 2 whole square plus 1 square. And I'm getting under root 9. And under root 9 is equal to 3. Now I will find the magnitude of vector B, and that is equal to under root 12 square plus 4 square plus minus 3 whole square, and I'm getting under root 169, and that is equal to 13. Now I will again write the equation 1. Cos theta is equal to dot product of AB divided by magnitude of A and magnitude of B, and cos theta is equal to, I know the dot product of AB is equal to 13 divided by, and the magnitude of vector A is 3 and the magnitude of B is 13, and 13 will be cancelled out, and I'm getting 1 divided by 3. Now theta is equal to cos inverse 1 divided by 3, and it is approximately equal to 70 degree. Remember that theta of dot product also tell us about the nature of two vectors. If theta is equal to 90 degree, then these two vectors are perpendicular or orthogonal to each other. And remember, if theta is equal to 0, then these two vectors are parallel to each other. If theta is equal to 180 degree, then we say these two vectors are antiparallel to each other. Now let me tell you about the properties of dot products of vectors. The dot product of V and U is equal to the dot product of U and V. Or we say the dot product of two vectors is commutative. For example, if I have a vector V which is equal to 2i plus 3j, and if I have a vector U which is equal to 5i plus 7j, and now the dot product of V and U is equal to 2 multiplied by 5 plus 3 multiplied by 7, and the dot product of V and U is equal to 10 plus 21, and I'm getting 31. Now the dot product of U and V is equal to 5 multiplied by 2 plus 7 multiplied by 3, and I'm getting 10 plus 21, and the dot product of U and V is equal to 31. So we can see that the dot product of V and U is equal to 31, and the dot product of U and V is also equal to 31. Hence we say the dot product of two vectors is commutative. Now remember, the second property of dot product is if I have two vectors, the dot product of two vectors U and V is equal to 0, then this means either U vector is equal to 0 or V vector is equal to 0, or we say that the U and V vectors are perpendicular to each other. Dot product of two parallel vectors is equal to the product of its magnitude. For example, if I have two vectors A and B, and I know the dot product of A and B is equal to magnitude of A vector to the product of magnitude of B vector and cos theta. Let this is equation number 1. Now the angle between two parallel vector is 0. Now what I will do, I will put the value of theta in equation 1. And now the equation, well, the cos 0, remember cos 0 is equal to 1. So I will get A dot product of B is equal to magnitude of A vector to the product of magnitude of B vector. Now what about the dot product of two anti-parallel vectors? Now here again I will consider two vectors and the dot product of two vectors. Let these vectors are AB and the dot product of AB is equal to AB cos theta. Now the angle between two anti-parallel vector is equal to 180 degree and cos 180 degree is equal to -1. So the equation number 1 will be shifted to the dot product of A and B is equal to minus magnitude of A vector to the product of magnitude of B vectors. At the end of this lecture, I will teach you that how can you check your answer or result. Before starting the lecture, click on the subscribe button and get access to our 100 of conceptual lectures for free. Let's consider a vector A in this direction and a vector B in this direction. Let both the vectors A and B are perpendicular. Let the components of vector A is equal to 5i plus 3j plus 7k, while the components of vector B is equal to 3i minus 2j minus 8k. Remember that I intentionally ignore arrows on vectors and heads on unit vectors for simplicity. Now if I ask you to find cross product of A and B, will you find it? I hope you can. Let me teach you a very simple method. First of all, look at the order of multiplication of cross product. I mean that A cross B is totally different from B cross A. So you must be careful about the order of cross multiplication of two vectors. Here, the order of multiplication is A cross B. Now firstly, I will write all the components of vector A in matrix form. There are three components of vector A and vector B. So I will draw three columns in this matrix as I, J and K. The first vector is A, hence put all the components of vector A in their respective columns and rows. So I put this 5i in I column, this 3j in 3j column and this 7k in k column. Now the second vector is B. Hence, I will put all the components of vector B in their respective columns and rows as I did for vector A. Thus, I put 3i in I column, minus 2j in j column and minus 8k in k column. As a result, I get 2 by 3 matrix. Now the next step is A cross B is equal to component of I minus component of j plus component of k. I write down empty matrix for I, j and k components. Well, we need to find the determinant of this 2 by 3 matrix. If you ask why you are finding the determinant of this 2 by 3 matrix, well, finding determinant will fill these empty matrix or finding determinant will provide us the components of I, j and k unit vectors. So we therefore find the determinant. Now the unit vector I is in the first row and in the first column. So cancel the first row and the first column. What is left behind? It is 3, 7, minus 2 and minus 8. So write here 3, 7, minus 2 and minus 8. We get 2 by 2 matrix for I unit vector. Now J is in the first row and in the second column. So cancel the first row and the second column. What is left behind? It is 5, 7, 3 and minus 8. So write here 5, 7, 3 and minus 8. Similarly, K is in the first row and in the third column. Thus cancel the first row and third column. What is left behind? It is 5, 3, 3 and minus 3. Now I can easily find the determinant of these 2 by 2 matrix. I again write A cross B is equal to component I minus component J plus component K. Now here 3 into minus 8 is equal to minus 24. Minus 7 into minus 2 is equal to minus 14. And this 2 by 2 matrix 5 into minus 8 is equal to minus 40. Minus 7 into 3 is equal to 21. And this 2 by 2 matrix 5 into minus 2 is equal to minus 10. Minus 3 into 3 is equal to 9. Now A cross B is equal to minus 24 plus 14 is equal to minus 10i. Minus 40 minus 21 is equal to minus 61 and to minus is equal to plus 61j. Minus 10 and minus 9 is equal to minus 19 and to plus is equal to minus 19k. Thus the cross product of A vector and B vector is equal to minus 10i plus 61j minus 19k. From this example, we also learned that the cross product of two vectors A and B is equal to a new vector. Or you can say that cross product of two vectors A and B generates a new vector C. Hence the cross product of A and B is equal to C. What about the direction of vector C? Well, we have A cross B. So curl your right hand fingers from A towards B. The thumb of your right hand points in the direction of vector C. So vector C is an outward or an upward direction. Thus by right hand rule, we can easily find the direction of A cross B. Here, let me give you two bonus MCQs. Firstly, remember that direction of A cross B in this case is upward, while the direction of B cross A in this case is downward according to right hand rule. That is why A cross B isn't equal to B cross A, because the direction of A cross B is upward while the direction of B cross A is downward. Thus A cross B is equal to negative B cross A. The negative sign indicates the opposite direction. Now at last, let me teach you that how can you check your result. Here I calculated that the cross product of A and B is equal to minus 10i plus 61j minus 19k. Either it is the correct answer or the wrong answer. Well, to check your answer correctly, you must note that the dot product of two vectors is equal to 0. We know that C vector is perpendicular to both A vector and B vector. So if the dot product of C and A is 0, then this calculation of A cross B would be 100% right. Otherwise, our calculation of A cross B would be wrong. So I will find the dot product of A and C. Remember that the dot product of two vectors are super easy. Just multiply the I component of vector A with the
I component of vector C, j component with j component, and k component with the k component, and then add them all. Hence 5i into minus 10i is equal to minus 50 plus 3j into plus 61j is equal to 183 plus 7k into minus 19k is equal to minus 133. Thus I get minus 50 plus 183 and minus 133. Now I write minus 50 plus into plus is equal to plus 183 plus into minus 133 is equal to minus 133. Now this minus 50 and this minus 133 is equal to minus 183. Hence this plus 183 and this minus 183 are cancelled out. As a result, we get 0. Thus the dot product of A vector and C vector is equal to 0. It means that vector A is perpendicular to vector C. Therefore, this calculation of A cross B is 100% right. Even if you find the dot product of B and C, you will get 0 because if C is perpendicular.
Polygon law of vectors. In this module, we will discuss about polygon law of vectors. Statement: if a number of vectors are represented as the sides of polygon, both in magnitude and direction, taken in order, the resultant is represented by the closing side of the polygon, taken in the reverse order, both in magnitude and direction. Polygon law of vectors is used for addition of more than two vectors. Let us consider 5 vectors: A bar, B bar, C bar, D bar, and E bar. Now, displace the vector B bar parallel to itself till the tail of B bar touches the head of A bar. In the same way, move the vector C bar parallel to itself till the tail of vector C touches the head of vector B. Again, displace the vector D parallel to itself till the tail of vector D touches the head of vector C. And displace the vector E parallel to itself till the tail of vector E touches the head of vector D. Now, a vector drawn from tail of vector A to the head of vector E. This will be the sum or resultant of vectors A bar, B bar, C bar, D bar, and E bar. Therefore, R is equal to A bar plus B bar plus C bar plus D bar plus E bar. This is polygon law of vectors.
Addition. Triangle law of vector addition states that if two vectors acting simultaneously on a body are represented both in magnitude and direction by two sides of a triangle taken in an order, then the resultant of these vectors is given by a third side of that triangle taken in opposite order. Let's say that an object moves from point A to point B and then from point B to point C. The displacement of the object from A to B is represented by the vector A, and the displacement of the object from B to C is represented by vector B. Now, let's join the initial point A of the first vector and final point C of second vector to get the sum or the resultant vector of the two displacement vectors. Vector C represents the sum or the resultant vector of the displacement vectors A and B, or vector A plus vector B equal to C vector. This is known as triangle law of vector addition. Magnitude of resultant vector. Magnitude of the resultant vector C is given by the relation C equal to square root of a square plus b square plus 2ab cos theta, where theta is the angle between vector A and vector B. Direction of the resultant vector. Let phi be the angle made by the resultant vector C with vector A. Then phi is equal to tan inverse B sin theta divided by A plus B cos theta. Let's take an example to understand this concept better. Question. Three vectors P, Q and R are shown in figure. Let S be any point on the vector R. The distance between the points P and S is B into mod of R vector. The general relation among vector P, Q and S is. Options are given. You have to find the correct one. This question was asked in JEE Advanced 2017 exam. Solution. Applying triangle law of vector addition in the triangle OPS, P vector plus B into R vector equal to S vector. Therefore, vector R equal to vector S minus vector P divided by B. Also, vector R is equal to vector Q minus vector P. Therefore, vector S minus vector P upon B is equal to vector Q minus vector P. This implies vector S minus vector P equal to B into vector Q minus B into vector P. Therefore, vector S is equal to B into vector Q plus 1 minus B into vector P. Hence, option A is correct.
Yes, children. So now the next thing is, after knowing about vectors, dot product, cross product and all of that, we will just solve how do you represent vectors A and B. Alright, so how is this representation done in a graphical method? Now, what does this basically symbolize? Okay, so if I have to find the area of triangle or something, does it give me a cross product? Can I find it by a cross product? All of that we will check out. Okay, now let there be any two vectors A and B. They are collinear vectors. Why? Because they are starting from the point O, right? The vector A and vector B, both the initial point starts from O. So A and B are called collinear vectors. Now what I'll do, this represents like a triangle, right children? So this is theta, this is the opposite of it, this is the adjacent of it, and this is called as the hypotenuse, the greatest side. Right? Now we know that area of triangle is what? Half base into height. Right? So we all know this. Since area of triangle half base is what children? OS and height is PQ. Okay? So half base into height. Now we know that. What do we know? Sine theta is equal to opposite divided by hypotenuse. Right? So sine theta. Theta is here. So this is opposite and this becomes the hypotenuse of it. So opposite divided by hypotenuse is sine theta, or sine theta is equal to, what is opposite here? PQ divided by OP. What is OP? OP is nothing but the hypotenuse, correct? So PQ I need. Why I am doing all this? Because I need what is PQ, right? So PQ is equal to OP sine theta. Now we already know something. What do we know? We know that vector OP. Yes, children. Now we will study a few properties of cross product. Now, what are the few properties of cross product? Now, few properties of cross product are, always remember, they cannot be commutative, right? Because direction is involved here. So when direction is involved, definitely it is not commutative, it is not associative, right? So the signs will change here. So A cross B is equal to not B cross A, but minus of B cross A. Then A cross B into A cross B plus C is equal to A cross B. So you should write it like A cross B plus C, right? So A cross B plus A cross C. Okay? Now, A cross B plus C cross D. First what we'll do is, this can be written as like this way. Okay? So I'll just explain you. So it is A cross B plus C cross D, right? So take the first term, that is A. Yes, children. So what I'll do is A cross B plus C cross D. Take the first term. A cross C plus D. Okay, so this term, when it will get multiplied by this, you will get A cross C plus A cross D. Correct? Plus, take the next term. B into this whole term. So it will be what? B cross C plus B cross D. Okay, so you'll have 4 terms. 1, 2, 3, 4. Understood? Now next. M into A cross B. M is some scalar quantity, some magnitude. Okay, so M into A cross B is equal to M into B cross A. Then B plus C into A. B plus C into A is nothing but B cross A plus C cross A. Alright, so this is one more property. Next, always remember, cross product of the same quantity is always 0. That means if one quantity is this way, the other quantity is the opposite way. And if the magnitude is the same, then definitely it is 0. So A cross A is 0. Okay, similarly B cross B, C cross D, no matter what you take. If you're applying a cross product, it's always 0. Then A cross B minus C is equal to A cross B minus A cross C. Yes, distributive property. Then A cross B the whole square is equal to A square, magnitude of A square plus magnitude of B square minus dot product of A dot B. Okay, and the last property, A cross B cross C is equal to A into C. That means dot product of A into C into B minus B into A into C. Okay, so whenever you have 3 cross products, then dot product will come into picture. So in detail about this, you will study whenever you are doing your mathematics. Okay, so it's the same concept. This we require for solving our physics problems. Okay, but in detail, how you got this, what you got it, what are the rules that you need to apply, all that you'll be studying in your mathematics class. Clear? So keep these properties ready so that it's easier for us to continue in the next class. I hope you understood till here. For any doubts, please do mail me, and let me all see you in the next class. Thank you. Study well. Take care.